Good morning, fifth graders. Hopefully, everybody had a great weekend. Today, we are starting Chapter 12, Lesson 3, box plots. We also know those as our box and whisker plots. So let's see where we can find our notes here. You are in your Google Classroom. Go over here to your classwork. Scroll down here to Chapter 12. Brings you to Chapter 12 here. It says Chapter 12 completed notes. Right here, your M6 Lesson 12-3 notes key are all right here. Click on those and we will go over the information. So let's take a look here. Chapter 12-3 box plots. Constructing a box plot here. You should be familiar on how we do that. We've done those in the past, so you should have a clear understanding how it works. I will review it as we do go through it. So it says a box plot or box and whisker plot uses a number line. As you see here, we have our number line right here. To show the distribution, means the spread of the data, by using the median, quartiles, and extreme values. The values are our outliers. A box is drawn around the quartile values. That's Q1, which is right through here, and Q3, all through here. There's the box that we are talking about here. And the whiskers extend from each quartile, so from Q1 to the lower extreme to Q3 to the upper extreme, but we do not include the outliers in this. This is something that is new to you. As you see here, this is the outlier we are talking about. Okay, the median is marked by a vertical line. Here's our median right here, by a vertical line. Put our dot here in the middle. And the figure below is a box plot. So let's go over a couple of things here to refresh your memory. So if we take a look here, scroll down here. Okay, if we were to think about what the data we have here, okay, this is our lower extreme. Our lower extreme is the lowest number that we have with the data set. Now, the upper extreme here is the largest, but the difference here is if it is an outlier, we do not include it. We use an asterisk to identify that this here is our outlier. Now, it says right up here, it says, if there is an outlier, move to the next point as your lower or upper extreme. We will talk about that in a second. So let's take a look here now. So as you see here, we have all of our information now. As you saw, we have our lower extreme, we have our upper extreme. When we ordered our data from least to greatest, that gave us our median. We figured out what the median is, which is placed right here. It looks around maybe 162 or so. Then to figure out what the Q1 is, we took our lower extreme and our median, and we found the median of those numbers there, which gives us the Q1 here. We put our dot here. This looks to be about maybe 122 or so. Then we also have our Q3. Our Q3 is our distance between our median. Now, we are including our outlier with this. To figure out what that median is there, which gives us our Q3 here. We'll talk more about that in a bit. And as you know, this is our upper extreme. As you know, we do put a box, this is known as our box plot, around our Q1 to Q3. And then, as you know, from Q1 to our lower extreme are our whiskers, and from Q3 to the upper extreme, that is our whisker there. Now, as you do know, it says the box plot separates the data into 4 parts. Even though the parts may differ in length, as you see, this is longer than maybe this piece over here. Each contains 25% of the data. So basically what we're saying is from the lower extreme to Q1, there's 25% of the data there. From Q1 to the median, there's 25% there. From the median to Q3, 25%. And from Q3 to the upper extreme, it makes up 25%. We also know that the box here in the middle, okay, it's a hard one. 25 plus 25 is 50%. That makes up 50% of our data here. So let's try an example here. So it says here, draw a box plot of the car speed data. So if we take a look here, we have our numbers here. The first thing we have to do is put them in order from least to greatest. So when we do that, we have 19, 20, 22, 23, 25, 25, 27, 30, 34, 35, and 40. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That makes our life a lot easier. So we go to the sixth one that will give us our 25 here. So that is our median. Our median right here is 25. Okay. So as you see, we plotted that right there with our 25 here. So now, when we're figuring out what our Q1 is, okay, we do not include this 25 right here. We can include the other 25, but not this 25 here. So we have 1, 2, 3, 4, 5. That makes life a lot easier when it's odd. So I have 2 on this side, 2 on this side. We can see that my Q1, okay, is going to be 22. We'll put that dot right there. Now we'll come over to this side over here. We will see, okay, I've got 27, 30, 34, 35, and 40. 2 here, 2 here. That makes my Q3. Q3 here is going to be at 34. We're going to put our dot here. Now, we have to figure out, okay, does this have an outlier? Okay, so remember how we figure out our outliers. We take our Q3, we have to figure out what the IQR is. Our Q3 minus Q1. So the IQR, 34 minus 22 is 12. Then we take that 12, we multiply it times 1.5. It's always 1.5. Remember that, which gave us 18. Now, with the lower portion of this to figure out whether the lower extreme is, we take our 22, our Q1 here, and then we subtract 18 from it. So you get 22 minus 18 is 4. Do we have any data points in here that are 4 or below? The answer is not. So is no. So that means 19 is our lower extreme. We put our dot here at 19. Now, let's see if it has an upper extreme. We'll take Q3. We go 34 plus our 18. So 34 plus 18 is 52. Do we have any numbers 52 or greater? Nope, which then means, hey, there we go. Our upper extreme is 40. Put our dot there. Now make sure we draw our box in whiskers. So here's a whisker from our 19 to the 22. And we can draw from our 34 to the 40. And then we put our boxes in Q1 to Q3. Put your box around here. And draw your line through your median here. So this is our box and whisker plot with no extremes. So let's see if our next one has any extremes here. Let's scroll down to the next one. It says here, okay, the list shows the speed in miles per hour of a commercial airline. So 540 all the way down to 515. So first thing I had to do I needed to put these in order from least to greatest. So I had 350, 450, 460, 475, 480, 500, 515, 520, 525, and 540. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's no fun. It's an even number. So that means numbers 5 and 6 are going to be used to figure out what the median is. So 1, 2, 3, 4, 5, and 6. Okay. So to figure out what that median is, I take my 480 plus 500 and divide that by 2. So 480 plus 500, divide that by 2 gives me a median of 490. So I can actually plot that one right here. So I have my median right here on my box and whisker plot. Now from that point, we have to figure out Q1 and Q2. Now remember, I do include this 480 here. I must figure out what the median is between my lowest extreme and my median here, because the median's right here. So it gives me 1, 2, 3, 4, 5. Oh, it makes my life easier. So 2 on this side, 2 on this side. Here is my Q1. Q1 is 460. So I can plot that point right there. Okay. Then let's go to my other side to figure out Q3. So I have to include the 500 here. 1, 2, 3, 4, 5. That makes life easy. 2 on this side, 2 on that side. 520 is going to be my Q3. Plot that right here. So first thing I need to do now, the next thing I need to do now is figure out, okay, is there an outlier? So let's figure that out. I got to figure out what the IQR is first. So I'll take my Q3, my 520, and I'm going to subtract that from 460. When I do that, I get 60. Now, what do I do with that 60? I multiply it times 1.5. Remember, to figure out the outlier, everything is multiplied times 1.5. So 60 times 1.5 is 90. So I come back over here to Q1, take my 460, subtract 90 from it, which is 370. Oops, guess what I have here? Let's make this in purplish color here. Okay, 350. Boom. I found my outlier. I'm going to make that into an asterisk. There's my outlier there, which then tells me right there, it says, if we have an outlier, go to the next value, which is 450. So this is going to be my lower extreme here. 450 is where my dot goes. Let's see if we have an upper extreme. So once again, I take my Q3, which is 520. This time I add my 90 to it. So 520 plus 90 is 610. So I look at that. Do I have anything 610 or greater? That is a no. So I know here is my upper extreme right here, 540. Put my dot in there. So here we go. We're going to do our whiskers. So from our new lower extreme, which is 450, I draw my line to Q1. I go from my Q3 to my upper extreme, so 520 to 540. So then from there, I do my box around Q1 all the way over to Q3 and then back across. And then once again, draw my vertical line through my median, and that gives us our box and whisker plot from there. Good job, guys. Here we go. On to the other side. Let's take a look there. We're going to now analyze our data here. We're just going to take a look at the information here. We're going to look to see how things are spread out. Okay, so here we're looking at car speeds again. Let's take a look at this one. It says half the drivers were driving faster than what speed. Now, as you know here, okay, we know this is 25%, 25%, 25%, 25%. So we know that, if I clear this here, that from this point on, 50% of the data is over here, 50% of the data is over here. So half of the drivers were driving faster, so faster than what speed? So this is my median here, is at 25. So half of the drivers were driving faster than 25 miles per hour. Okay, it says, what does the box plot's length tell you about the data here? Okay, now when they say the length, what are we saying? We're looking at this distance from here to here, this distance from here to here, this distance from here to here, and this distance from here to here, because that tells us about the spread of our data here. So it says the length of the left is short, okay? So if we look right over in here, this area here is short, okay, which means the data is concentrated. It's tighter together here. If we even look over in here, it's tight here also. Okay, it's about the same length as this side compared to that side there, which means that data is tight together. So we have a lot of the data maybe around our 19, 20, 21. We have a lot of numbers there in that range there. Compared to, so it says the mean, it says this means that the speeds, that the slower half of the cars are concentrated. So if we're looking at the slower half of the cars. That's this side here. Okay. We have a lot of people that are going slower because this is not very spread out. Now let's look at the other side of it. It says the speeds of the faster half are spread out. So if we look at this side, this is the faster half over here to the right. You see this data here is spread out. So our numbers are more spread out because they're going from 25 to 34. They're more spread out. Remember, that still only contains 25% of the data. And also here from 34 to 40, there is all that information is also spread out also, and that's another 25% of the data there. Okay, let's look here at the other side here. It says speed of the airliners. Okay, so if we take a look here, yes, there's our outlier there. So it says half of the commercial airliners travel slower than what speed? Okay, here's our halfway point, which means 25 or slower. I'm sorry, 50% are slower that way, and 50% are slower that way. So if we take a look here, that halfway mark, okay, is at 490 miles per hour. So let's look at the spread here. Let me clear this. As you notice, hey, this side from here to here, this from here to here, this from here to here, this from here to here are all approximately the same size. If you compare it to this over in here, you can see there's a huge distribution of the data here. Here, all the numbers are basically condensed about the same. They're evenly distributed is what we say. So the lengths are equally distributed and spread out, okay? So they're not a huge spread, they're concentrated, but they're all about the same, okay? So it's an even distribution. So let's look down here. Let's see what else we have down here, okay? So it says the box plot below shows the daily attendance at a fitness club. The median and the measures of variability. It says find the median and measures of variability. Okay, then describe the data here. So if we were to look at this stuff, okay, let's start here with our median. Okay, now yours may not be exact, but we should be pretty darn close here. Okay, there's our median there. If you look there, it's about 72.5. Okay, so 72.5 the people is our median attendance. So can we figure out the range? Of course we can. Of course we can. Now, to figure out the range, there's a little bit of a difference here. See, we have an outlier here. We include that with the range. Okay, so it's 110 minus our smallest value here, which is 56. Our range is 54. Let's figure out what the IQR is. Remember, we go Q3 minus Q1. So we got 80 minus 65 is 15. There is an outlier at 110. So we did find all of our key information here. So if we take a look as we move down here, it says the whiskers are approximately the same size, so the data without the outlier is evenly distributed, okay, below and above the quartiles. So basically what it's saying here is, hey, take a look at this data here. This is about the same size as this. And guess what? These here are about the same size also. So there's an even distribution, okay? If we were sort of look at this, it's sort of like a bell curve. Okay, with the center being our median here. Now, this is why we remove the outlier here. If I did not, then hey, look how the distribution is affected with this distance from Q1 to the outlier. That's why we remove the outlier and we go with the next number beside it, which was our 90. Okay, let's look at the next side here. It says the box plot below shows the average low temperatures for July. Find the median and measures of variability, then describe the data. Okay, daily low temperatures in July. So let's figure out what we have here. Okay, we know that our median, okay, is right here. So this is 56 degrees Fahrenheit here. Our Q1 is going to be 54. Here's Q1 right here. Our Q3, we're going to call 59. Okay, so if we figure out what our range is, it doesn't look like there's any outliers here. It sort of looks like, I mean, we could call, yeah, we'll call it 59. Yeah, we'll call it, I like that. We'll go with that. So if we do our range, they're calling our 60. Yeah, this is 60 here. 60 minus our, this should not be 10 here. This should be 50. So make sure you change that to a 5. Okay. 60 minus 50 equals 10. So we know our range here is 10. The IQR, we're going to take our 59 minus our Q1, which is going to give us a 5. And there are no outliers at all. So as you take a look at this here, let's take a look here. The right half is more concentrated than the left. So if I split this down the middle here, you can see this length here compared to this length here. So that means there's a smaller gap between our numbers here, which means they're more concentrated. So they're not as spread out. So hopefully you understood how everything worked today. That was all that we have here for the box plots. Chapter 12, lesson 3. So make sure you understand it. If not, rewatch the video and get started on your homework, or you can wait to do your homework tomorrow. Take care, guys, and have a great day. Bye-bye.